Hello, my name is Julia Lima, and I will be presenting RSV, respiratory syncytial virus, a respiratory tract infection. So RSV has a few common names to it. The most common name, as you can tell by me presenting, is RSV, respiratory syncytial virus. Another common name for RSV is HRSV, human respiratory syncytial virus, and the scientific name for RSV would be human orthopneumovirus. Now, for those interested in going into the taxonomy of RSV, it is listed here to the right. So a few common RSV characteristics would be that of just the general nature of RSV. So RSV is an enveloped, single-stranded, non-segmented negative sense RNA virus. In infected individuals, they can be contagious for 3 to 8 days upon infection. And this period of time of contagiousness can possibly be up to 4 weeks. And this is if the person infected has a weakened immune system. And RSV can live on hard surfaces and can be airborne for many hours. Meaning, if it's airborne, meaning it's a respiratory disease. So RSV, as you can see here, this is the general structure of RSV. You have your F proteins and G proteins on the outside, and then you have your DNA within the lipid envelope. And going further into these extracellular proteins, these would be your causative agents. So there are 2 types of proteins on the outside. You have your F proteins and your G proteins. Your F proteins would be the ones responsible for fusion of viral and host cell membranes. And so they kind of mesh up together the 2 membranes. And then your G proteins are the ones responsible for the viral attachment to host cells. Now, there are 2 forms of G proteins. You have your membrane-found form, and you have your secreted form of the G protein. The membrane-found forms are responsible for attachment by binding to glycosaminoglycans on the surface of host cells. And your secreted forms, they act as a decoy. They interact with the APCs to inhibit antibody-mediated neutralizations. So a good way to think of the secreted form of G proteins would be that of a Trojan horse, where it acts as a decoy, further allowing the virus to replicate and just travel throughout the body. So there are a few possible reservoirs of RSV. RSV is a strictly human virus for replication and infection. So humans are the dead end of this virus. It's very rare for an animal to be infected with the virus. Normally, transmission doesn't occur after infection, but as you can see here, animals such as mice, cotton rats, sheep, and African green monkeys have been known to be infected with some of the strains of RSV. And the only animal that has, or the ability to transmit the disease, would be chimpanzees. Now, all these animals were not infected with the disease naturally. All these animals were artificially infected within clinical studies. And so RSV is very much a human virus when it comes to if it came up naturally or not. So there are a few methods of transmission. As I mentioned before, RSV is an airborne virus, so it can remain in the air for quite some time, I believe up to 2 hours. And so how it gets in the air, this can be due to coughing, it can be sneezing, vocalizations, or there's another method of transmission, and this can be through direct contact. So if an infected individual wipes their nose and puts their hand on the table, and then a non-infected individual comes up touches the table and then maybe scratches their nose, mouth, or eye, then the virus can enter into the body through those portals of entry. And with coughing and with sneezing, this will spread the virus through the small particles in the air, making it airborne. So there are many symptoms of RSV. The most common symptoms for adults would be typical cold-like symptoms, so coughing, sneezing, runny nose, body aches, and fever, that sort of deal, in addition to wheezing in many cases. And then symptoms in younger children, such as infants or toddlers, usually happen to be more severe. Approximately 40% of infant cases result in LRTIs, which are lower respiratory tract infections, such as bronchiolitis or pneumonia. And in the most severe cases, these LRTIs can potentially result in the death of the infected person. However, there are some clinical studies that believe there's a link in severe RSV infections within early childhood and asthma later in life. But this is very underdeveloped research. I only briefly saw it, and I thought it was really interesting how an infection from early in life could potentially cause asthma later in life. So when thinking of RSV, you have to think of the at-risk populations for the disease. And this would be the extremes of the age boundary. So you have your infants that are less than 6 months, as well as young children, and you have your older populations. And especially children who have nosocomial infections or previously underlying health conditions are at most at risk due to their new immune systems going through and being weakened by these earlier infections. And as you can see here, the numbers speak for themselves. So among children in the USA, about 2.1 million patient visits came from children younger than 5 years old. And within these visits, you have 58,000 hospitalizations among children that are younger than 5 years old. And within the older population, though there are even more hospitalizations at 177,000 for adults older than 65. And among those hospitalizations, you have 14,000 deaths per year among these older populations. And to further go into how RSV spreads, I just wanted to give a quick mention to how the pandemic has affected RSV and its infection rates. And so, as you can see in the previous years, for 2017, 2018, 2019, 2020, there was a steady rise in these infections during its infection seasons. And its seasons normally last 4 to 6 months. And as you can see here, it's in the hundreds of thousands. These numbers to the left represent the infections in the thousands. So 500 is actually 500,000, and so on and so forth. So as you can see, there are millions of cases within the last few years. However, these cases dropped dramatically when the COVID closures occurred. And this would be due to the preventative methods of COVID, such as social distancing, wearing masks, and other methods such as hand washing, and just making sure to keep better hygiene when it comes to yourself and others. And with all these measures in place, the amount of infections dramatically dropped. As you can see, at one point it was reaching 2.1, 2.2 million cases in 2020, and it dropped to less than 100,000. So these are a few of the effects of the pandemic that involves RSV. And going through the preventative methods, there are a few preventions when it comes to RSV. though there's still no vaccine. And vaccine development began in the 1960s. However, the very first vaccine was unsuccessful. The vaccine that was given to the patients was the formalin inactivated RSV vaccine, the FI-RSV vaccine. And this vaccine induced severe inflammation within the lungs. And in two cases, these were lethal responses to the vaccine. And these responses became known as VRDs, which stands for Vaccine-Associated Enhanced Respiratory Disease. So these vaccines, instead of protecting the individual, actually induced respiratory diseases. And so they're still searching for a way to produce vaccines, because as you can see, this is a very contagious disease as it's airborne, and there have been millions of cases in the past. Though there are other options, such as wearing a mask, hand washing, and just overall health education of how disease spreads in schools and just in offices to prevent RSV from spreading. And then I would like to go over the references very quickly, as you can see here. Thank you.